Hello, I'm Mr. Ray, and today we'll be looking at another aspect of differential calculus, which is function of a function or chain rule. If y is equal to 3x squared plus 2x plus 4, we say y is a function of x, because as x changes, y also changes as well. The change of y with respect to x is given by dy all over dx. Okay, let's say that x is also equal to sine theta plus cos theta. So here we now say x is now a function of theta, because as theta changes, x also changes. So now we can find the rate of change of x with respect to theta, and this will now give us the x all over the theta, because x is a function of theta, dx over theta, y is a function of x, dy over dx. Y is a function of x and x is a function of theta. So we call this a function of a function. That's what we'll be looking at in our today's class. This table gives the standard derivatives or the special derivatives. These are derivatives we are supposed to have at our fingertips as mathematicians. You are supposed to know that if y is equal to sine x, dy over dx is equals to cos x, as we have it here. This is what you are supposed to know. But this table is not restricted to just x. If y is equals to sine theta, here we have dy over d theta is equals to cos theta. And if y is equals to sine p, dy over dp is equals to cos p. If y is a function of x, we differentiate with respect to x. If y is a function of theta, we differentiate with respect to theta, and so on and so forth. Okay, let's quickly look at this example together. If y is equal to sine 2x, find dy all over dx. If you look at this table carefully, we have if y is equal to sine x single term, dy all over dx is equals to cos x single term. We have single terms here and single terms here, but here we're having double 2x if y is equals to sine x. So the first step is to make it a single term so that these rules can be applicable. So we can now say let 2x is equals to u, or u is equals to 2x. So this equation 1 now becomes y is equals to sine u. So we can now apply this. If y is equals to sine p, dy over dp is equals to cos p, and so on and so forth. So here we have dy all over du is equals to cos u. But we are looking for dy all over dx. So this is not the final answer. Here, x is a function of u. So from here, du all over dx is equals to 2. Generally, if y is equals to ax, dy over dx is equals to a, just the coefficient of x. So du all over dx becomes a coefficient of x, which is what? 2. So now we have dy over du and we have du over dx, but we are looking for dy over dx. If you look at this chain rule, and the chain rule is given by dy over dx is equals to dy over du times du all over dx. If you look at this u can take care of this u. So we are on point. So what is the value of dy over du? We have cos u times 2, which is equals to 2 cos u. But what's the value of u? U is equals to 2x. So the final answer becomes 2 cos 2x. So dy over dx is equals to 2 cos 2x. But if this was a multi-choice question, you don't need to do all of this. We can now conclude that generally, if y is equals to sine ax, dy over dx is equals to a cos ax. The same thing is applicable to other trigonometric ratios. Okay, here we're asked to differentiate y is equal to bracket open 2x cubed plus 3x bracket close all raised to the power of 3. In other words, we are asked to find dy over dx. But generally, if y is equals to ax raised to the power of n, where a is a constant, dy over dx is equals to n will multiply a, then you subtract 1 from the power. But here we just have it as x. We can only apply this when we have it just one term as either x or u or p. But here we're having a function. So we cannot apply this to a function. We cannot just multiply this function by 3 and subtract 1 from the power, because what we have here is a function. So the first step is now to make this function just a single thing. We can say let u is equals to 2x cubed plus 3x. Or let this be equal to u, so that this equation 1 can be same as y is equals to u to the power of 3. Here, x is a function of u, and we can differentiate u with respect to x, and that gives us du all over dx. And 3 will multiply 2, and we subtract 1 from the power. So here we have 3 times 2x, 3 minus 1. Here the derivative is just the coefficient of x, which is 3. I've explained this earlier. So we have 3, and this now becomes 6x squared plus 3. Let this be u. If this is equals to u, this equation 1 now becomes y is equals to u to the power of 3. So y is a function of u, and we can differentiate y with respect to u, and that gives us dy all over du, which is equal to, the power here is 3, and the constant a is equal to 1. So 3 will multiply 1, that still gives us 3. Then we subtract 1 from the power. 3 minus 1, that gives us 3u squared. But we are neither looking for dy over du nor du over dx. Rather, we are looking for dy over dx. So we can apply the chain rule, where dy over dx is equals to dy over du times du all over dx. What is dy over du? From here, the result is 3u squared times du all over dx, which is 6x squared plus 3. So the final answer now becomes 3. Then the u, from here, u is equal to 2x cubed plus 3x. So we substitute this for u, and it becomes 2x cubed plus 3x all squared times 6x squared plus 3. So that's the final answer. So if this was an objective question or a multi-choice question, all you need to do, just assume that this is u. So it becomes 3. Just dy over dx is equals to 3 multiplying the function, which is 2x cubed plus 3x. You subtract 1 from the power and that becomes square. Then you multiply it by the derivative of the function and that gives us 3 times 2, 6x squared plus 3, and that gives us the same answer there. Thank you for watching.